Thanks to UA Mobile for having me here. Uh, I'm new to conference speaking. I've done it 2 times before this year, um, but it's always nice to have conferences that are open to having people in that is not just a known face that they see in many other places, but actually bring in new people. So I'm very thankful for that. Um, so like less than 2 hours ago, this was on my laptop. I'm using deck sets for my slides, and they have like a private beta with some features that I'm using in my slides, some custom styling, which I like. And then I didn't check that the app was actually expired. So a big thanks to Pavel Dudek, which helped me out and supplied me with a beta just last minute. So he was really quick to respond, and yeah, he's the reason that I can actually do a talk with proper slides today. So yeah, big thanks to him. This is the first time I'm in Ukraine. Um, I haven't seen much of Ukraine. This is kind of what I've seen so far. I came in very late last night. It was dark, and then I woke up this morning, and this is the current state of the weather outside. So I'm looking forward to going to Kiev, and I'm sure it's a lovely city, and I'll see more of it. But it's quite nice. It's some nice shades. So it's um. My name is Tobias Munk, and I'm from Copenhagen in Denmark, or at least that's where I live now. I'm from Denmark originally, other parts of the country. I do consultant work, and I make my own apps from time to time, just to keep the indie dream alive. You know, like good clients giving money, indie dream not making any money. So that's always fun. Right now, I just shipped an app called Slør, which lets you edit portrait mode photos on iOS 11. So just very shortly, it's you can open a portrait mode photo that has depth information, and then you can see on the right, you can see like a grayscale of the depth, and then you can apply different blurring effects to the image based on those depth data. So it works on the 7 Plus and 8 Plus iPhones and the iPhone 10. Yeah. And you can make pictures like this taken on an iPhone. I think that's quite awesome that you can kind of push the boundaries of what you can do with a cell phone camera. Cool. So enough about me. We are here to hear something about GameplayKit. More specifically, I'm going to talk about some specific gems from GameplayKit. GameplayKit is a framework that is available on iOS, on tvOS, and on macOS. It's not available on NotchOS. Oh, wait. WatchOS. So just keep that in mind that if you're going to use anything from this, if you're doing a watch app, you cannot use it in those parts of it. At least not yet. It might eventually be there. Is anyone making watch apps these days? Ish, maybe? Cool. So this is Apple's pitch. It used to be their pitch on GameplayKit when they introduced it. It says, unlike high-level game engines such as SpriteKit and SceneKit, GameplayKit is not involved in animating and rendering visual content. Instead, you use GameplayKit to develop your gameplay mechanics, to design modular, scalable game architecture with minimal effort. I kind of want to change or challenge this a little bit. So I just think you should use GameplayKit to develop with minimal effort. And that's kind of why we're here today. Basically, take things from GameplayKit and then use them in non-games. Just a normal native app. So I should take this one away when I'm coughing, right? That's still learning. So I've added some break slides just to remind myself to breathe slowly throughout the talk, and also a lot of my kind of training for doing talks has come from watching WWDC videos, and probably a lot of you have seen those as well. Like every summer, new videos come out and you watch them, and it seems like all of them have the same person training them to do the talks. So I need to do this thing. I have 4 things to talk about today. So let's just dive into the first of the 4 gems. Shuffling arrays. Code. So this is what I would call a naive approach to shuffling arrays. You go on Stack Overflow, you find the first answer, and you copy paste the code, and then you have something that can shuffle an array. The thing I don't like about this is it has a lot of casting stuff back and forth between different types, and it kind of reads like a C API parts of it, and it just doesn't look nice. And who can read this code and make sure that there are no errors in it? And so you have to test it, and you have to do all different kinds of things to make sure that the code actually works. The way this specific part of code actually works is that it has like a random uniform distribution that it's sampling from, and then it kind of randomly goes through an array, and then or like consecutively going through an array, finding a random next item, and then shuffling with that one, and then when it's all at the end of the array, then things are somewhat shuffled. It works really well. We could wrap it up in a convenience method and sequence, and then just use it from there. And then we can now have an array. We can say that we want it shuffled, and then we have a shuffled array. So instead of having 0, 1, 2, and 3, then suddenly we have 2, 1, 0, and 3. And you could use this for like a Spotify app if you want to shuffle a playlist or something like that. But that's not really what we're here for, right? At least I'm here to talk about GameplayKit. I don't know why you people are here, but you probably know. So GameplayKit has something called arc4 random source. It's pretty similar to the other uniform distribution that I used before. But this one actually has an option to seed it with a specific number. It's quite nice when you're testing things that you can do random things, but still seed it with a number so you know it returns the same result every time. But besides that, you can use it for shuffling an array of objects. So here we use the source, and then we call like array by shuffling objects on the array, and then we get something similar as what we did before. And this is actually the second most upvoted answer on Stack Overflow. So yeah, Stack Overflow to the rescue. There is a similar function on NSArray if you import GameplayKit that actually does exactly the same. It's just a different API to the same functionality. This is the one I'm going to use on the next slide. So it's kind of nasty with GameplayKit sometimes. It has some very Objective-C types, types, yeah. So here I'm just kind of wrapping it up. So I have an NS array, casting it as an NS array, the array as an NS array, and then afterwards, when we have the shuffled one, then it's returned as like an array of any's, and we know that they are actually of the type that we used to have, like the element type. So we can just force cast it to that one as well. And then we can do exactly the same thing as we had before. We have our array, we can shuffle it, and we get a shuffled array back. The thing I like about this approach using GameplayKit is that you have less of your own code, and you have less code that you need to test. Usually, a good thing is not to test system frameworks. Then you kind of gone too far in your testing craze. But you also kind of avoid having code that people feel like they need to rewrite. If you have your own code, you have a new member on, they think, well, I think you should optimize this, do something different. And here you're just saying, well, there's a first-party solution. I'm just using that one, and it works just fine. So so that's the first gem on the agenda. My notes say that I should use the entire stage. There's not a stage here, so I'll just do it, particularly to annoy the cameraman. Done. So so let's get on with the next one. Performant visual search. Naming is hard, right? I don't know. This was the best that I could come up with for the next gem that I'm here to tell you about. Imagine having a lot of items on the screen, and the user might want to make a selection on all of those items. It might be like a MindNode app where you have a lot of boxes and labels and arrows, or it might be a map where you have a lot of pins on the map. So basically something where you don't use native components for the UI, where you have a lot of items of them. And then when the user kind of makes a rubber band selection, then it selects different of the items based on their selection. And you kind of want something like that to be smooth and responsive to when the user is dragging around. But if you have tons of items, then you might not get the performance that you would want. So let's just look at the naive approach to how you would solve this, like the first approach. Imagine that we're having 3 dots, just some simple 3G CG points. And then we create a bounding rect, so a rect representing the selection. Here is fairly simple. It's just like a 1x1 one frame. So if we look at the first 3 items and we have this selection, can someone in the audience tell me which of these points lie within this selection? First and the second. Good. You're ready to get a job at a very big company with very good money. Awesome. I will not give you a certificate. I don't have those. So the way that we probably would implement this is Core Graphics has a function on a frame where you can say, does it contain the CG points? And here I'm just filtering over all the dots that I have, and then ask if it contains it, and then it would then just return the 2 first points that we saw before on the other slide. And this might be fine. Like this actually works quite good, and the computation done in this function is not that heavy, so it's not that bad. But you might run into a problem where you can't push all the 60 frames per second, or maybe even the 120 frames per second on the new iPads. And even though devices become faster, then sometimes you just hit a bottleneck. If you do, GameplayKit to the rescue. So GameplayKit has something called R trees. It also has some other different trees. They have quad trees and they have oct trees. I didn't study computer science, so I never heard about these ones before I saw this stuff. And I'm not that much into how they actually work. But what they do is they kind of make a structure around all the components that you give to it. So instead of having a simple array where there's no order to things, a tree is kind of a structure that, well, it's kind of like a tree, so it's branching out, and then it kind of has a known structure for the data inside, and then when you're searching it, you can do it faster because it already knows some things about the structure of the data that you have. So let's see how this is actually implemented. Unfortunately, GameplayKit has some weirdness with types. And as objects, that's just ugly. But, well, that's what we do. We could wrap it in a container or something and then do something like that, but that's kind of missing the point of doing something more performant, that we have to wrap something all the time. So here we just make a point type that inherits from NS objects and live with it. It's very similar to CG point, right? You have the X and you have the Y value. And then the tree, as I mentioned, has this structure. So what we do is that we're pre-filling the tree with all the points that we have, and when we're doing it, it then builds up the structure internally. So the first thing we do is even though we have a point and it has an XY, we kind of have to tell the structure visually where that point is. So we are creating a vector type. It's just like a one-to-one translation for the X and the Y coordinates. And then we add the point along with the description of where it is. So we're adding the points, and then we're adding, telling it that it's positioned between, like its minimum rect position is the vector and the max is also the vector. So like it's an infinitely small point somewhere. It could have a size as well if you wanted to have kind of some padding on it. But here's just infinitely small. And then there is a parameter on the add element method that's called the spread strategy. I don't know what they do. They work differently. It's about what happens when you add a point, like how does the archery decide where you put it. Basically, it's something that gives different performance. Like it works well for different cases. So just like anything, profile your code, play around with it for common use cases, and see what works the best. You might know about these different strategies. They have like reduce overlap, half, linear, and quadratic. You might have a good idea about which one would actually work the best. You probably don't. So just test it and see which one works the best for your case. It just gives a different tree structure internally. So the last step is that we actually have our selection, and then we need to, again, wrap it in some, or cast it to a different type. And then the API can consume it the way it wants. And then now we can take our tree and ask it for all the elements that are inside this selection. And then we get, again, just as before, we get our 2 points back. So this is quite a bit of setup. Before we just had an array and we just had like 3 lines of code to just do the filtering on it. And that worked really well. So here we do have more setup, but the setup is the thing that is actually giving us better performance. And you could wrap many of these things in some, like make a wrapper API around it, and then things would look nicer and you wouldn't have to care so much about the somewhat ugliness of GameplayKit when used in Swift. The archery also has a couple of more settings that can tweak performance. So it has something called the max number of children, which is basically that each branch, how many branches can it have before it's splitting out and doing things. And then it also has something called the query reserve, which is when you're searching the tree for items, if you know that you're likely to get like 1,000 items back, you can kind of tell the archery that that's what you're expecting. So when it runs its algorithm to actually do the search, it can initially make a container that has the size enough, like in this case, for like 100 items. So it doesn't have to, so it can just like pre-allocate all the memory for the search that you're doing for it. I'm sorry, I have a bit of a sore lung. Not pneumonia or anything, but I'm good at this thing, right? So now we can do a new selection just using our new code. You can see it's much faster, right? It's just because I'm switching faster through the slides. But it actually works faster in the test case that I set up. I know the people at MindNode, they use this for some of their selections in their UI. And they kind of have some features that they couldn't do if they didn't use something like the algorithms that GameplayKit provides. So this is definitely one of those real-world use cases, something you can actually use out there. So this is this was the second item. 2 down, 2 to go. Ooh, I have a new thing I need to try. I should look naturally at the audience. I don't know how you do it. Like, I'm not good at it. Like, you're looking quite naturally back at me. That's nice. Not that many people sleeping yet. So let's get on to the third item. This is I don't know if this is the favorite. I like all of them, but I think maybe this is my favorite one. Natural randomness. So random. This is what you do, right? We saw it before with the shuffle arrays, the arc4 random. If you want to have like a value between 0 and 1, you can normalize it by the max int value. But sometimes random just isn't enough. Random fluctuates a lot. There's no kind of continuity in the samples. So if we have something like an equalizer in an app, and just imagine this is from an equalizer in the I don't think it looks like it. But then we kind of, all these values are just sampled from that simple uniform random distribution. And we go through it, and we make a new. And it doesn't really look like something that is produced by analyzing sounds or something like that. You might actually want to do an actual equalizer on sound if you have an app that plays back audio. But for many reasons, you might not want to. Maybe you don't have access to the audio stream because it's in a video or whatever. So let's take a look at how we can actually make some noise that is not just uniform random. And of course, GameplayKit is here to save the day. GameplayKit has different noise sources. They have Perlin, Rigid, Billow, and Voronoi. Voronoi is the one that looks like cell structures when you see it. I don't know how you would pronounce it. It's probably more Eastern European than either my fake English or my Danish. But Voronoi is a quite nice one. So in this case, I'm just looking at the Perlin noise source. It has some different parameters: frequency, octave count, persistence, and lacunarity or latunarity. I don't know. The frequency is kind of just how quickly the noise is fluctuating. It has some fluidity to it. And the octave count is like if you have the base frequency, then you have some octaves on top of it, so multiples of 2 and 3 and 4. In this case, we're giving it an octave count of 3, so it probably has the multiple of 2, 3, and 4. Persistence is kind of how quickly do the octaves tail off, like what is the amplitude of them compared to the base frequency. And then the last one, the lacunarity, is something that kind of decides what is the distance between the octaves. So instead of being multiples of 1, then it could be multiples of 1.1 or something like that. In this case, multiples of 2. Yeah, if you have a noise source that should resemble a piano or something, then usually the lacunarity is not 1, but 1 point something a little bit. So some phenomena in nature are not just like very precise multiples of 1 when they have octaves, but has some kind of I don't know what you would call it, but some kind of imperfection that kind of gives it a natural feeling. So it's quite nice that the Perl noise actually has a parameter like this. If you're going for like the really nice, perfect match noise source that is not perfect but natural. I don't know. So the noise source is something that can be taken to another abstraction layer that is called noise. I'm not actually going to use it for much in this example, but you could use it for combining different noises. So if you have a lot of different noise sources, you can combine them using the noise. So you can multiply them or divide them or add them, subtract them. You can even clamp them and things like that, or transform them. So they provide some different values back in certain ranges, and if you want values in other ranges, you can kind of tell it to do it for you, so you don't have to do the calculation. So now we have our noise. We can put it into a noise map. In the noise map, we kind of tell it how big it is. In this case, it's 3 by 5. And then all the samples within that map will have some sort of continuity between them. So they will not just fluctuate as if they don't know about each other, but they will kind of have some smoothness to kind of, if you imagine that it's representing a surface or something, it kind of has a smoothness to it. And now we can sample the app, sample the map. Sorry. In this case, the 0 origin points, and then we can go in one direction. Here we go in like the x dimension, and in this one, I'm going in the y dimension. And when we're doing this, as I mentioned, they have some fluidity between the different samples. So imagine this is kind of going in the x direction, and then we kind of like all the samples kind of follows a baseline or like some sort of smooth curve, but they do have some fluctuations around that. So that's kind of what you get with these noise sources. And if we then go in like the y dimension of it, then we can kind of do an animation. It's a bit choppy in the beginning. That's because it's not loading as fast as it should. But you kind of get the point that it's you're kind of slicing through the map with all of these different values, and then you kind of get some smooth result out. And I think this looks more like what an equalizer would produce. it's not exactly perfect. I don't know what animal would make a sound that looks like this, but you can probably find one. So that's the third item. Right on time. And now on to the final item on the agenda. Nice, pathfinding. So imagine that you are at a conference, and you have to find your way around. You probably just did, right? Like, where is the iOS room? All the way in the back. Just, I don't know, maybe they don't want you to find it. Maybe it's too small, so they kind of need to make sure not that many people get down here. But at least you found your way. But imagine that you had an app where you could guide you to this place, right? GameplayKit, of course, has stuff that can help you do that. So this is a map of Tivoli Gardens in Copenhagen. It's an amusement park. It has different amusement parky stuff. It has a lake. Don't walk into the lake. So, and don't walk into buildings. So that's kind of what I'm trying to solve here, like to make pathfinding around the amusement park without walking into things or getting wet. So I went to OpenStreetMap, got the data for all the different things that are in this region, and then here I just plotted it on the map. So what we can do is that we can define obstacles based on these same data. Here I'm just making a polygon obstacle, so it can be any polygon, and then I'm defining what would be a 1x2 square, I think. You're the one with the big money from the big company. Is it the 2x1 square or? Yeah, it is. Good. Okay. So I made a mistake here. I did this, and I spent at least 2 hours, maybe a full day, because I made a mistake. Stuff just didn't work when I tried to use it. It should be defined counterclockwise. So when you're defining an obstacle, you kind of, what I did in the first case, like in this one, I'm going clockwise. So the obstacle is actually everything outside of the region that I'm kind of defining. So if you want to pathfind in an obstacle, you can't do that because the definition of pathfinding is that you can't walk in an obstacle. So the API just didn't return anything, and I didn't understand why it didn't work. It turns out you can read the documentation. So maybe that should be the title of this talk, read documentation. But if you just do this one, and not this one, but this one, then it actually works. So do this one. So now we actually have a working obstacle that is defined in a counterclockwise fashion. Then we can add it to an obstacle graph. Here I'm just adding like one obstacle. In the amusement park case, it would be, I don't know, 10, 100 obstacles. And then we now have this map defined in the obstacle graph. And what we wanted to do was to walk maybe from point A on the left and to point B on the right, without walking into the lake and without walking into buildings. So the first thing we do is that we define the 2 points as graph nodes, the A and the B. And then for the graph, we are actually adding the node to the graph. So the thing is that the way that I understand it, at least, is that the graph is kind of building up a lot of subpaths, like all minimal paths between all the different obstacles that we added to it, or at least like the corners of the obstacle. And then afterwards, when you're asking it to go from one place to another place, well, it has subpaths for all the different, like for all the different corners of the obstacle, but it doesn't know about how to get from point A to point B, because it doesn't know where point A is, or at least it didn't make subpaths to point A. So you have to do this. You have to ask it to connect using obstacles to node A. And then it magically creates all those extra small subpaths, and then when you afterwards actually ask it to go from A to B, it knows how to do it. So again, if you don't do this, this doesn't work. And of course, this doesn't give any meaningful error message whatsoever when you do it without doing the first one. Just silent, like it's just, you can't, I can't do that. Like it's just like the array is just empty in the path that it returns. So that's kind of sad. Cool. So this is the array that is returned. The only reason it returns an array is because we defined our obstacles counterclockwise, and we added the connect using obstacles node for the from to the for the A to the B position. And as you can see, like the first point here, I don't know if I think it's big enough. The first point is our leftmost point, like the from point, and the last point is the 2 points, and then the 2 points in between are kind of like corners on the obstacle, the bottom corners of it. The path is actually just as short going like on the upper side of the obstacle. Fortunately, GameplayKit is deterministic, so it doesn't like flip back and forth between those two solutions. So when you keep asking it, even though the distances are the same, it's deterministic and gives you the same path on the downside all the time, which is quite nice. So you don't see flickering in your app or unexpected behavior. Cool. And the graph obstacle has one small parameter that you can add to it when you're creating it, and that's a buffer radius. So it's basically kind of like a buffer around all the buildings. So maybe you don't want people to walk into buildings, but you also don't want them to be able to touch the building, because it's a very nice and precious building. I don't know. So here you can kind of define the buffer radius around all the obstacles, and then you can see the points that we get down here. Instead of that these 2 points were actually exactly next to the obstacle, it's like exactly the 0.5 point away from the obstacle. So that's handy if you kind of need some small padding to it. In the example for the amusement park, I used like a very small padding that was similar to I think maybe like 1 meter or something like that, and it gave a little bit better results, I think. So now we can go from A to B. That's quite nice. So if you come to Tivoli, just go from A to B, and that's awesome. You can maybe buy some ice cream at the end, if it's sunny. Cool. So that was the 4th item, and that's my cat. Okay, I have some slides now that don't look nice. I'm on time. I'll fix the slides and then I'll come back. Highly professional, right? Well, I'm back. You can just cut from here and then. Do anyone have like a cut board? Like, no. I want one of those next time. So we went through shuffled arrays. We went through performant visual search, natural randomness, and pathfinding. Someone told me to do a summary slide for this talk the last time I did it. So here you have it. This is the summary slide. Supposedly, it makes you remember this stuff much, much better. So, DC, right? I'm really excited to see what you're going to make with this. That's it for the bad jokes. So here are some links. I'll share the slides afterwards so you can just click on them. Apple has quite good documentation for GameplayKit. They kind of have some introduction to it and thoughts about how you should use it and what you can use it for, which is quite nice, particularly for someone like me that haven't done game development before and didn't know about a lot of these algorithms. So it's kind of like opening up the world of the algorithms that it has for you to use. Natalia Berdis did a talk at Try Swift last year, which I quite liked. it had some of the stuff that I showed in these slides. If you want more of the noise stuff, this talk is quite nice. Has some quite good demos of the different noises and what you can do with them. And then Sats actually did a Medium post on this a while back, which shows some other things that are in GameplayKit. So more stuff than just the 4 items that I showed. And then someone has a post on the right way to write Dijkstra's algorithm in Swift. I think it sounds quite awesome. What it actually is, the Dijkstra one is the way you do pathfinding. So that's the one that Apple also used in GameplayKit. So if you want to kind of know more about how it actually works. And then all the code examples are on GitHub, following this link if you tap it, where you can actually see the code working and functioning. So it's not just fake code on the slides, it's actually working code. And if it doesn't work, then you can fix it and make a pull request. So that's nice. Questions? That's it. No, we don't have the other microphone. Did someone swallow the other microphone? If we have no questions, there's not an issue. Any questions? No? Good. Thanks.